The ideas expressed in the following presentations are those of the speakers and do not necessarily reflect the views of ACI or its committees. ACI web sessions are recorded at ACI conventions or other concrete industry events and will be made available for viewing free of charge for 1 week. Thereafter, they will be archived on the ACI website or added to ACI's online CEU program, depending on their content.
Our first presentation is the NRC Participation and Perspectives on Codes and Standards for Nuclear Construction. And we are very pleased to have Carol Moyer, the team leader, international programs of the U.S. Nuclear Regulatory Commission. Please welcome Carol Moyer. Carol?
First thing I need to correct is the team leader of international programs was actually a temporary assignment that I was fortunate to have for the beginning several months of this year. I am back to my regular job, which is a senior program manager of codes and standards, so that's why I'll be talking about codes and standards today. Okay, first, since this is my first opportunity to be at an ACI meeting, I thought perhaps some would not be familiar with who the NRC is, what we do, so I had just a brief introduction here about the NRC itself. NRC was formed in 1974 when we were split from the Department of Energy and established as a separate commission. We regulate commercial uses of nuclear material, and everything else that used to be Atomic Energy Commission became Department of Energy. We are headed by 4 commissioners and a chairman, appointed by the President, confirmed by the Senate. So we currently are in an interesting situation. We have one new commissioner who came on board a couple of weeks ago and another one who will be sworn in this coming week. And our chairman has announced that she'll be leaving the agency at the end of December to go back to academia. So we're in flux a little bit right now, but that's why we have 5 and on staggered terms so we can maintain our continuity. We have around 4,000 staff members. We have our headquarters here in the Washington area, 4 regional offices, and then resident inspectors at power plants and fuel cycle facilities. As I said, we license and regulate the civilian use of byproduct source and special nuclear materials to ensure adequate protection of public health and safety, promote common defense and security, and protect the environment. So we cover plants, we cover medical uses, we cover waste storage or spent fuel storage. What we don't do, obviously, is the weapons side, the military side of radiological technologies. So what do we do as a regulator? Well, we establish rules and regulations, we issue licenses, we provide oversight, we do inspections and enforcement activities. We can also conduct research. I work myself in the Office of Nuclear Regulatory Research to provide technical bases for our regulatory decisions. And we also, when necessary, respond to emergencies. The photo that's at the bottom there is our new operations center that just went online this year, or late last year, I guess. So it doesn't look like this most of the time, but if there's an exercise going on or if there's something genuinely interesting going on, like the Fukushima disaster, for example, then we had a lot of technically proficient staff in our ops center 24/7 monitoring what was going on and helping us make regulatory decisions. Okay, as concrete folks, you're probably interested in what we're doing with the construction program, construction inspection. There are 4 plants being constructed now in the U.S. And a couple others that were started and stopped and are now being completed. We ensure that the plants are constructed in accordance with the approved designs and safety regulations. We determine operational readiness so that they can move then from a construction phase into an operation phase and ensure an effective transition to operations. We have an office of new reactors office, NRO, and we have a Nuclear Reactor Regulation Office, NRR. So a plant that is started under the oversight of our NRO office will then move to NRR once they are fueled and online. Also, part of what NRO does is vendor inspections. We don't certify or accredit vendors, but we do inspect them for compliance to regulations and oversee audits of vendors. Because we now have a global supply chain, the NRO staff is doing a lot of international travel and doing some joint inspections with other regulators and with various licensees to make sure that the vendors supplying parts for new plants are meeting all the rules. One thing that's of concern right now is counterfeit or suspect items, so we're trying to maintain a special vigilance for that to make sure that there's a proper paper trail for all the new components. Okay, so I came here to talk about codes and standards. Codes and standards are integral to what the NRC does. They promote safe operation of power plants and other uses, obviously, of nuclear materials. And we as a government agency, believe it or not, are actually interested in doing our jobs effectively and efficiently and making the most use of our limited budgets. So those are the reasons that we're interested in using standards. And oh, by the way, there's also a federal law that says we have to, unless there's a good reason not to. That's the National Technology Transfer and Advancement Act of 1995. And its implementing guidance, the OMB Circular A119. These say that a federal agency should use a voluntary consensus standard rather than developing its own standard unless it can show a particular reason not to. Like there isn't a standard available or the standards available don't meet the need that we as a regulator have, so we can in some cases develop our own standard, but we try to make wide use of consensus standards. So why? Well, as I said, it increases efficiency rather than having us start from scratch. We think that it leads to safe operation and practical requirements. There should be a safety benefit for the requirements that we have, and if there's not a good cost-benefit analysis for a new safety requirement, then it won't make it through the standards process. People will say we don't need to do this. There's not a sufficient benefit to make it worthwhile to make that change. Once it makes it all the way through that process, we believe we should have a cost-effective result. This is an overview of the one way that standards are used, and that is the most formal way through rulemaking. The NRC is responsible for the part of the federal rules called 10 CFR, which is Title 10 of the Code of Federal Regulations. We'll see that in shorthand. When a standard is placed into a rule, it is called incorporation by reference, and that standard becomes law. It becomes a legal requirement. So this is considered the most formal version of NRC endorsement. The standards that are used, that are endorsed in rulemaking, as I said, become licensee requirements. They become laws. We have a rule called the backfit rule that applies to us as a regulator that says there must be a cost benefit. There must be a safety benefit in order to make a change in the rules that is appropriate for the cost of what that change would be. And it's a complicated way to say that, but essentially it means if we as the regulator said all plants must do the following, and all of our licensees said, but that will cost us millions of dollars and make only a tiny difference in safety, then it goes through some review committees, and if they couldn't make the case for it, then we would not be able to require that change. We could suggest it, we could request it, but we can't require it, even though we're the big federal government. Just for perspective, in other countries that isn't always the case. There are other regulators that are able to say, no, you will make this change, and we don't really care what it costs. But here in our free market society, we don't have that. We're often criticized that it takes us a very long time to endorse standards, that sometimes we're a couple of versions behind, and, what's the matter with you that you take so long to do this? So I wanted to make sure that you understand that we have a rigorous process that we follow when we consider a standard and when we go through the rulemaking process. The process includes this backfit rule requirement. It includes a review by the Advisory Committee on Reactor Safety, the ACRS, and it also includes public comment and resolution of those public comments, and then it's usually issued as a draft rule, and we get comments, and then we resolve those comments and then issue the final rule, and then there's some delay also before it takes effect. So it takes a couple of years, sometimes longer, to go through this whole process, but as I said, it's a rigorous process so that hopefully we have a good quality result. As I said, 10 CFR is our neighborhood in the Code of Federal Regulations. 10 CFR 5055A is entitled Codes and Standards. That particular part of the CFR incorporates by reference the ASME Section 3 and 11 codes, the Operation and Maintenance codes, and some specific code cases having to do with dissimilar metal welds. It also brings in various code cases, which are kind of trial changes in the ASME code that are brought in through regulatory guides, which is actually an NRC document, and I'll get to that in a minute. We also incorporate by reference to IEEE standards having to do with safety systems and protection systems. Okay, regulatory guides are another document that the NRC issues, and these are, in general, not requirements. These are implementing guidance for requirements. So these are methods that the staff considers acceptable, but they are not in themselves regulations. They have forward fit applicability. They are a wordier document than the rule typically, so they have we have the ability to capture the staff position, kind of why we what the not requirement, but what the suggestion is, and then why we have that suggestion or why we have that requirement if it's tied to a rule. These, however, also are formal documents. They go through ACRS review. They go through public comment. So they still can take 1 to 2 years to write or to update. But most of our standards that are cited formally are in reg guides. Some of these you may find to be more familiar. ACI 349, Code Requirements for Nuclear Safety-Related Concrete Structures, is endorsed in Reg Guide 1.69 on concrete radiation shields. It's also in Reg Guide 1.142, Safety-Related Concrete Structures for Nuclear Power Plants other than vessels and containments. And it's endorsed in part in Reg Guide 1.199, Anchoring Components and Structural Supports. Another code familiar to you, ACI 359, Code for Concrete Containments, is endorsed in Reg Guide 1.136, Design Limits, Loading Combinations, Materials, Construction, and Testing of Concrete Containments. Let's see. I put up a couple of other reg guides that might be familiar to you, and just to give you a little more perspective on our use of standards in reg guides. The ASCE 4305 seismic design criteria, their standard is referenced in our Reg Guide 1.208, a performance-based approach to define site-specific earthquake ground motion. And AISC N690, specification for design, fabrication, and erection of structural steel for building, is endorsed in our Reg Guide 1.206, combined license applications for nuclear power plants. So this covers the licensing approach for new construction, including such designs as the AP1000 that uses the steel concrete composite structure that's going to be described in the new version of N690. There are some other ways that the NRC uses standards besides rules and reg guides. Standard review plans, inspection procedures, standard designs, individual licenses. There are other places that these can turn up. But as I said, the formal means of directing licensees to use standards are really rules and reg guides. Okay, so We believe that using standards is a preferred approach. It gives us various advantages, including reduced resources, reduced costs, faster reviews, greater predictability, wider acceptance. When you have a voluntary consensus standards development process, you have the stakeholders who are interested in that standard working together to create the rules that make the most sense and that are most cost effective. Once the standard is set and published and we have endorsed it, now we have predictability, you have stability in our regulation, which is something people ask about too, because we are now referencing that specific edition of a standard. I didn't say it before, but one thing I should mention is that we are, in general, not able to make what are called dynamic references. So we would not endorse ACI 349, period. We would always put in one of our documents a particular revision number or publication date or something like that for a specific standard, because we can't legally make our rules open-ended that way. You know, we have to have a rigorous technical review and regulatory review and then lock down that standard edition. Again, this can be a problem when people say, well, there are 3 editions published since then, why haven't you kept up? Well, there's some resources required, obviously, for us to do those internal reviews and advisory committee reviews and public comments and all of those things. So we have to have a good reason to go through those steps. However, if a licensee feels strongly that they would like to use a later edition of a standard, then they have to let us know that, and we will certainly take that into consideration. If there are industry users for it, then we'll consider using that standard. So the question is, well, how do we gauge this demand then for new and revised standards? Certainly one has to make the case. If there are vendors and utilities that want to use the standard and can show us that there's value added in it, and then they make that case, then we'll prioritize that higher. One way is to get an NRC staff member to participate in developing the standard. If you have staff on the committee, then they are tuned into what the committee is doing, and you have that channel of communication into the staff as well. If you you can then request that staff member consider that standard in the next revision of a reg guide or a rule. You could present the standard at an NESCC meeting, and I'll get to that in a minute too. Or even, the most direct approach, send a letter to our NRC Standards Executive. I mentioned at the beginning this OMB Circular A119. That set up a structure whereby federal agencies have a designated person called the Standards Executive, and some standards developers will routinely send us a letter saying, we have published the following standards and we hope that you will consider them for endorsement. It's at least one way to get our attention. So NESCC, I threw that acronym out a minute ago. This is the Nuclear Energy Standards Coordinating Cooperative. It's a very cumbersome name, but it's a forum that has been around since at least 2009 with the help of ANSI to help us do the logistics for it. So I'll blame ANSI for the name, but that's okay. They help us a lot. So it's a forum of standards users, such as the NRC and the Department of Energy and NIST, and standards developers, such as ACI and ASME and IEEE and NFPA and all of those other letters that you hear bandied about that are standards developing organizations. The goal of NESCC is to prevent gaps and overlaps between standards in the development process so that we don't have competing standards. We have people working on standards that are going to be genuinely useful to the industries and well understood by the regulators. We hope, in fact, to encourage collaborative development of priority standards. We have been asking the SDOs to communicate their priorities to us. What are the things that they are most working on? And we have communicated to them as well. These are the things that we hope ASME, for example, should be working on. We have a regular exchange of priorities with the American Society of Mechanical Engineers. We don't have anything quite that formal with the other SDOs, but we're working that direction. I'll put up here, these are a couple of reports that the NESCC has published recently. One on concrete and one on concrete repair have been circulated well, I think, and gotten a lot of good comments. They also did one on high-density polyethylene piping, taking some of the progress from the natural gas industry and applying that to surface water for nuclear power plants. And we're trying to turn that into kind of a roadmap for future development as well. So just to wrap up, NRC makes extensive use of codes and standards, and we hope effective use in regulations and reg guides and standard review plans and various other documents. We use codes and standards written by numerous standards developing organizations, and the staff of the agency are involved in these writing committees and involved in setting priorities for development of new standards and revised standards. Internally, we are actively revitalizing our process to use and endorse codes and standards. Candidly, that's my job, is to herd the cats of all the people within the agency that are working in the standards area. We have a lot of experienced staff members doing good work for good technical reasons, but not necessarily doing a great job of talking to one another and approaching things strategically. So in hopes of improving the effectiveness and efficiency of what we're doing, we're trying to make some changes inside. And thank you for your attention. I think we have questions.
We have time for questions now.
Time for questions now.
So, yes. Any questions? Yes.
Yes, sir.
When is that draft, that reg guide
The question was, when is the draft reg guide for supplement N9 going to be issued? And I do not know the answer to that off the top of my head, but our website has a list of regulatory guides, and including the draft guides. I think there's a way to click over from the published reg guides to the draft guides, and that should give you an indication of whether it's out for public comment. If the public comment has been completed, then it does take us a few months to address all of the comments and reissue it as a final. But I think that would give you the best hint. I'm sorry, I don't know the answer to that offhand.
Just wondering, subsequent license renewal is going to be bringing in a lot of unplowed ground, and the standards really aren't read. What are your thoughts, I guess, on the SOR stuff? Or it's just going to be a lot of brand new ground? You guys must have.
Yeah.
What do you think about it?
Sure. We have, within NRR, we have a division of license renewal that's looking at that. And they've done a lot of work on the technical side through the Generic Aging Lessons Learned report, the GAL report. And there's a parallel effort internationally. There's an IGAL that has been published that looks at international operating experience and trying to understand what happens in longer-term operation. Just for those of you who aren't in nuclear, the initial plant licenses were for 40 years. We've had license renewals for an additional 20 to take them out to 60 years operation at the bounding case. Subsequent license renewal looks at the possibility of whether, with certain upgrades and regular maintenance, could plant licenses be extended beyond 60 years out to 80 or some other number beyond that. We have a lot of effort in that area, and this codes and standards, I think the standards developers would say that they have kept pace and are addressing the concerns with degradation mechanisms and understanding what can happen and trying to bound those cases. But the NESCC forum that I mentioned has put SLR as one of their primary topics. So they're trying to bring together some collaborative effort in that area. As I mentioned, NESCC is partly led by Department of Energy, and they have a light water reactor sustainability division or organization. So they are very much involved in that as well.
Can you comment on the state of expectations for the upcoming nuclear plants that might be in line? I realize that there was a big push and there was a big expectation. Yeah. Some of those have been scaled back now. But do you have any sense, or what the next 5 or 10 years? Has this thing fallen behind? Is there
Well, the question is, what does the horizon look like for the nuclear industry for the next 5 or 10 years or so. 5 or 10 years ago, we had rumblings of a nuclear renaissance, that we were going to build 40 new plants and we were going to completely revolutionize the nuclear industry in America. Most of that has been scaled way back, but there are still people very much interested in building, and what you're seeing is two different communities, two different kinds of users, two different approaches to building new nuclear. One is the large plants, the AP1000s, and I think Ken might be talking about some of that in a minute. Yeah, ESBWRs. Yeah. So the big plants, the 1,000-megawatt plants. A few of those are in the pipeline and getting close to being done, and that's been the kind of traditional approach. You build a big plant, you get the economies of scale, and you have the power distribution infrastructure to support it. Now, the other approach is small modular reactors. The idea with that is you start with a small plant, maybe 50 megawatts, maybe 100 megawatts, and you build a couple of modules, and then you can potentially add modules to it later as the power demand grows and as the grid grows. This is very popular as a concept anyway, in other countries right now where they may not have the infrastructure to support a 1,000-megawatt plant. You could plop down a Vogtle-sized plant in the middle of their country, but it still wouldn't really help that much because they just don't have the infrastructure to get the power out to the users, or they don't have a big industry user that needs that much power at one time. So SMRs are more attractive. So we heard there was going to be a nuclear renaissance to build a bunch of big new plants. That kind of didn't happen. Then we heard, well, okay, then the next big thing is small, and we're going to have a bunch of small reactors, and that really hasn't panned out so much in the U.S. either. DOE has put up some money for the mPower project, and NewScale is working. I'm sorry. Thank you, NewScale. We're running out of time. Right. So I don't know. It remains to be seen. It's exciting times, but we as the safety regulator are scrambling to make sure that our rules are up to date to deal with whatever eventuality comes. But what the industry decides to do remains to be seen.
All right. Thank you, Carol. Thank you very much. Very good. Thank you, Carol.